In 1954, the Fields Medal honored a man whose work reshaped the language of geometry itself. Kunihiko Kodaira of Japan. He built bridges between two great branches of mathematics, geometry and algebra. Each spoke its own language, and for centuries mathematicians had to choose sides. Kodaira found the blueprint that connected them, showing that a curve drawn on paper could also be written as an equation, and that an equation could describe a shape. He turned separation into structure, and in doing so, unified mathematics itself. Think of the universe as an endless folded landscape. Hills upon hills, valleys within valleys, too vast to ever walk across. Kodaira was the mapmaker who figured out how to flatten those unseen lands without losing their shape. With his theorems, he made the invisible terrains of higher dimensions understandable on paper, like turning clouds into maps. What seemed chaotic and unchartable became ordered and measurable. Born in Tokyo in 1915, Kodaira came of age in a Japan racing toward modernity, a time when science and philosophy intertwined. As a child, he was drawn not only to numbers, but to music. He once said, "Mathematics, like music, is about harmony, a search for balance among patterns that feel infinite." After earning his degree at the University of Tokyo, he began teaching, but his real passion was the frontier of complex geometry, where algebra met analysis in mysterious ways. After the World War II, his brilliance caught the attention of the legendary mathematician Oscar Zariski, who invited him to Princeton. It was there that Kodaira's ideas would change mathematics forever. In Princeton in the late 1940s and 1950s, Kodaira began solving problems that had eluded mathematicians for decades. He proved the Kodaira embedding theorem, which showed that a complex manifold, an abstract higher dimensional surface, could be represented as a projective algebraic variety. In simpler words, he showed that every smooth, curved world described by complex numbers could be drawn using algebraic equations. Geometry and algebra, once separate realms, became two languages describing the same reality. Then came his classification of complex surfaces, a monumental achievement that organized all two-dimensional complex manifolds, an infinite zoo of shapes, into just a few families. It was like creating the periodic table of geometry. These results didn't just solve mathematical puzzles, they unified mathematics itself. For this breathtaking synthesis, Kodaira was awarded the Fields Medal in 1954 alongside Jean-Pierre Serre, marking the first time the honor went to a Japanese mathematician. The echoes of Kodaira's theorems reach far beyond pure mathematics. His insights form the backbone of modern string theory, where the geometry of hidden dimensions shapes the laws of physics. In algebraic geometry, his methods underpin entire fields, from mirror symmetry to complex differential geometry, which power advances in both data science and machine learning. Whenever physicists describe a universe curled in 10 dimensions, or computer scientists model high-dimensional spaces, they walk through corridors Kodaira built decades ago. His work turned the abstract into the tangible, a bridge between imagination and structure. Returning to Japan in the 1960s, Kodaira became a guiding force in rebuilding its mathematical community. He taught at the University of Tokyo and later Yale, mentoring generations of thinkers who carried his vision forward. His research remained elegant and quiet, always guided by a musician's sense of form and balance. Kodaira believed mathematics was not about power, but purity, the clarity that comes when structure and intuition meet. He passed away in 1997, leaving behind the harmony he spent a lifetime uncovering. Kunihiko Kodaira transformed how we see space, not as emptiness, but as a symphony of structure. He taught the world that the beauty of mathematics lies in its ability to unite the opposites, the analytic with the geometric, the real with the imaginary. His vision still sings through every equation that seeks order in the infinite.
If this story gave you chills, smash that like button. Share it with someone who geeks out on genius. And drop a comment if you think minds like this still shape our future. Because this is Awards, where the world's greatest minds live forever. Don't just watch history, be inspired by it.
Thanks for being with Awards. Subscribe to know more about international award winners and unsung heroes behind peace, science, and humanity.